Okay, in this section, we're going to be talking about trigonometric identities. And by definition, a trigonometric identity is an equation involving trigonometric functions that is true for all values, not just most, but all. No matter what you're talking about, it will always be true, for which every expression in the equation is defined. The identities help evaluate functions. We can simplify expressions with it. We can verify identities, and we can solve equations. So these identities are going to be important across the board. We're going to start out with some basic, and each of these can be proven. If you remember from the last section, the sine of a function is equal to y over r, and cosine was equal to x over r. Now, if you were to do sine over cosine, you'd get y over r over x over r. When you flip and multiply it, you would get y equals y over x. And if you remember, y over x was equal to tangent. So therefore, that brings up our first quotient identity. The tangent of a function is equal to sine over cosine. And you could actually prove several of these that exact same way. So make sure that we know this. And we've got to remember that this is only true when cosine is not equal to 0. We can't divide by 0, so cosine can't be 0. Cotangent is equal to cosine over sine, which is the reciprocal, and sine can't be 0. We've already talked about the reciprocal identities, and you see all of those listed here. Sine is 1 over cosecant, cosecant is 1 over sine, and so on and so forth. So we've got to make sure that we know all these identities. Okay, next up, let's actually use these identities. We're going to use these identities to find different trig values. And here's how we're going to do it. It says use the quotient and reciprocal identities to find each function value. If we have secant, well, how can we find cosine? Well, we know that secant and cosine from right here are reciprocals of each other. So if we're given secant, we can do cosine is equal to 1 over secant, which is simply going to flip it. So the cosine of theta, let me zoom in just a little bit, would equal 1 over negative root 30 over 3, or that's going to flip it, and that'd be 3 over negative root 30. Let's rationalize by multiplying top and bottom by root 30, and that gives me 3 root 30 on top, and it is still negative, and then 30 on bottom. And we can reduce 3 and 30, and that gives me a 1 and 10, so negative root 30 over 10. That's it. If tangent is equal to root 2 over 4, cosine is equal to this, then find sine. Now, we again simply find an identity that relates sine, cosine, and tangent. And it was the very first one that we talked about. We know that tangent is equal to sine over cosine. So therefore, let me write that. Tangent will always equal sine over cosine as long as cosine is not 0. So if we have tangent, we're going to plug it in here. So I have root 2 over 4 is equal to sine over cosine, which we see is equal to negative 2 root 2 over 3. And then that just sets up a simple equation that we're going to solve. To get rid of divided by, we're going to go to the other side and multiply. So we're going to do times negative 2 root 2 over 3. And that cancels that out. So that gives me sine is equal to, let's multiply our tops. Root 2 times root 2 is 2. So we have negative 2 times negative 2, which is negative 4 over 3 times 4 is 12, is equal to sine. And you can put the sine of theta, sine of x, whatever they're talking about. A lot of times I'll just leave that off and just put sine. So reduce that and you get sine is equal to negative 1/3. And that's it. If cosecant is equal to 7/3, cotangent is equal to negative 2 root 2 over 3, then find the secant. And we can look back, and I don't see any that relate cotangent, cosecant, and secant. Actually, the only ones that relate cotangent with anything is I know cotangent is cosine over sine, and I know that cotangent is the reciprocal of tangent, and that's about it. However, if you remember that cotangent, since it's equal to cosine over sine, well, we know that cosine is the reciprocal of secant. We know that sine is the reciprocal of cosecant, so we could actually use that to find this. So let's write down that I know that the cotangent of an angle, of any angle, so you can put the angle if you want to, is equal to the cosine of that angle over the sine of that angle. So if we're given the cosecant, let's start there. If cosecant is equal to 7/3, that's implying that the sine is equal to 3/7. So now we can use this along with the fact of us knowing cotangent to find actually cosine by using this. And once we have find cosine, then we pretty much have found secant. So the cotangent, which is negative 2 root 10 over 3, is equal to the cosine over the sine, which is 3/7. To get rid of division, we're going to mark it out, and we're going to come over here and multiply. The 3's will cancel, and that leaves me with cosine is equal to negative 2 root 10 over 7. But however, that is cosine. We're asked to find the secant of the angle, so therefore the secant would simply be the reciprocal of that, and I can throw that beta in there anytime I want to. The secant of beta would be 7 over, and that's just negative, 2 root 10. That's rationalized by multiplying top and bottom by root 10. And that gives me negative 7 root 10 on top. It gives me 2 times root 10, which is 2 times 10, or 20 on bottom. We have some new identities. They're called the Pythagorean identities, and probably some of the most useful identities that we have in our entire arsenal here. Anytime you have squared, sine squares, cosine squares, tangent squares, secant squares, cosecant squares, a lot of times they're going to be connected to these Pythagorean identities. Notice what the Pythagorean identity says. It says that cosine squared plus sine squared will always equal 1. That stems from the fact that remember that your cosine and sine values are x and y values on your unit circle. And that unit circle is actually x squared plus y squared is equal to 1. That's the equation of our unit circle. And you can see that that fits along perfectly with cosine squared plus sine squared is equal to 1 because, again, of those values being on the unit circle. Your second one, now I do want to show you, if you can remember your first one, if you can remember sine squared or cosine squared plus sine squared equals 1, then you can use that to actually find the other ones. And let me show you how you can do that. You can actually take cosine squared plus sine squared is equal to 1. Go through, and there's 3 terms here, and divide everything by cosine squared. And look what happens. Anything divided by itself is equal to 1. Plus sine over cosine, I know is tangent, so sine squared over cosine squared will be tangent squared, equals 1 over cosine is equal to secant by the reciprocal identities. So you have 1 plus tan squared equals secant squared, which is actually your second Pythagorean identity. And you could actually do the exact same thing. Let me erase this. But instead of dividing everything by cosine squared, if you were to go through and divide everything by sine squared, look what happens. We know that cosine over sine is equal to cotangent, so cotangent squared plus anything divided by itself is 1 plus or equals 1 over sine is equal to cosecant, so 1 over sine squared would be cosecant squared. So cotangent squared plus 1 is equal to cosecant squared, which is your third trig Pythagorean identity. So if you can just remember this one, you can find the other two by dividing everything by cosine squared and dividing everything by sine squared. So the next one says use the Pythagorean identity to find each value of the function. Now we worked these problems again in previous chapter. The way that we worked them was we said, okay, if sine is negative, cotangent is negative, what quadrant are we in? We drew a right triangle. And we said that since the sine of theta is equal to negative 1/3, sine is opposite over hypotenuse, we use Pythagorean identity, which is very closely related to the Pythagorean, or we use the Pythagorean theorem, which is closely related to the Pythagorean identity, to then find that. So let's do it this new way, though. If we're given or find cosine and tangent if sine is equal to negative 1/3, well, I know that the relationship between sine and cosine is that sine squared of an angle plus the cosine squared of that angle is always going to equal 1. So here's the sine. Let's plug it in. By the way, sine squared, anytime you have the squared right here, they put it there to show you that it's not the angle being squared, it's the whole thing. Sine squared theta means the sine of theta, all squared. So when we plug it in as negative 1/3, we're going to square that whole thing. So plus cosine squared is equal to 1. Negative 1/3 squared is 1/9 plus cosine squared is equal to 1. Let's move the 1/9 over by subtracting, and you get cosine squared is equal to 8/9. So therefore, to get rid of a square, we do plus and minus the square root. That's going to be plus and minus. We can simplify the top. Again, we split this. The bottom square root of 9, which is 3. The top is the square root of 8, which is 2 root 2. Try that again. So therefore, there's your answer. That's cosine. However, it says plus or minus. The reason it's plus or minus is we've got to figure out what quadrant it's in. Sometimes cosine's positive, sometimes cosine is negative. We're given up here that sine is negative. So let's remind you, all students take calculus. Since sine is negative, we know we're not here, and we know we're not here because sine is positive there. Cotangent. It says cotangent is also negative. Cotangent is the reciprocal of tangent. If cotangent is negative, then tangent is negative. We know tangent is positive here, so therefore we can scribble it out. So we must be in the fourth quadrant. Therefore, since we're in the fourth quadrant, cosine will be positive. So there's your cosine value. Now, how do we find tangent? Now that we have cosine, we know that tangent from our quotient identity, tangent is equal to sine over cosine. So therefore, tangent will equal, since I have sine, which is negative 1/3, and since I have cosine, which is 2 root 2 over 3. Now, here's the nice thing about this, is anytime you're dealing with these, your bottoms are going to be the same. Because we know that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse. So those bottoms should be the same. And what's going to happen when you flip and multiply is those bottoms will cancel each other out. And it leaves you with negative 1 over 2 root 2. Let's rationalize by multiplying top and bottom by root 2. And we get negative root 2 over 2 times root 2 times root 2 is 2 times 2, or 4. So negative root 2 over 4 would be your tangent value. Okay, number 5 asks us to find tangent as sine given secant. Now, if we have secant, let's remind you that if secant is equal to 6/5, then that means that cosine is equal to 5/6. They're reciprocals of each other. So now we're given that cosine is positive and sine is positive. All students take calculus. So let's see where we're at. Since cosine is positive, first off, that means that we cannot be here and we cannot be here because cosine is positive. Since sine is positive, that means we can't be here, so we must be in the first quadrant. So that tells us what our, whether we're going to be positive or negative, what our SIGN signs are going to be. And we are going to be positive on everything. So since we now have cosine, let's find sine. The way that we're going to find that is I know that sine squared plus cosine squared will always equal 1. Since I have cosine, I'm going to plug it in here. So now I know sine squared plus 5/6 squared is equal to 1. That'd be sine squared plus 25 over 36 is equal to 1. I'm going to have to subtract 25 over 36. Let me find a common denominator, which would be 36. Now when I subtract, I'm given that sine squared is equal to 11 over 36. So sine is equal to, we got to do plus and minus the square root of 11 over the square root of 36, which is 6. Again, since we're in the first quadrant, though, instead of plus minus, we can dump the minus. We know that our answer has to be positive. Okay, next up, it asks us to find tangent as well. So let me change colors here. Since I have cosine and I have sine, then I have tangent because I know that tangent is equal to sine over cosine by the quotient identity. So that means that tangent will equal, the sine was the square root of 11 over 6. The cosine was equal to 5 over 6. When you flip and multiply, your 6's will cancel. It's going to give you root 11 over 5. And when you're using that identity, since there's no plus minus, you don't have to worry about the positive and negative because that identity actually takes care of the positive and negative for you. Okay, some more identities. You have cofunction identities. Says that the sine, and we've actually talked about these, whether you knew it or not, when we kind of discussed when you were working with sine and cosine, that the sine of 30 and the cosine of 60 is the same thing. Well, that's this identity. The sine of an angle is equal to the cosine of 90 minus the angle. The tangent of an angle is equal to the cotangent of 90 minus the angle. Secant is equal to cosecant, same thing. So every one of these works. You also have even and odd identities that says if you have the sine of a negative angle, that you could actually kind of move that negative out front. So like the sine of negative 30 would be the negative sine of 30. The cosine of negative 30, however, would be the cosine of positive 30. You can drop that negative when you're dealing with cosine. Why is that true? It's because sine is actually an odd function. If you remember back that when we're talking about odd and even functions, if f of negative x equals negative f of x, then it's an odd function. You can see that here. If f of negative x is equal to f of positive x, it's an even function. So this is an even, this is an odd function. Here's an odd function, and then in the middle you have two even functions. So both of these are even functions, and the ones on the outside are odd functions. So it says here, use the cofunction identities and the even and odd identities to find each value. So let me zoom in. So here, the cosine of 90 minus theta, or pi over 2 minus theta, we'll define that. That's going to equal, let's scroll back up. From right here, the cosine of 90 minus theta is going to be the same thing as the sine of theta. So let me go ahead and write that. So what we're looking for, this is going to be the exact same thing as this. Well, I know that the sine of negative is giving me this, and I know that it says the sine of negative theta by the even odd identities will be the same thing as the negative sine of theta. So if the sine of negative theta is negative 0.97, let me fill that in. That's negative 0.97 is equal to the negative sine of theta. So if I were to move that negative back over by dividing by -1, that makes this a positive now. So that means that the sine would be 0.97, which is what we're looking for. So the cosine of pi over 2 minus 90 should equal 0.97. The next one asks me to find the cotangent of alpha minus pi over 2. Let's go over here and look. And you don't see one that fits that. You have all these other ones. So how are we going to find the cosine of alpha minus pi over 2? Well, let me remind you a little bit about factoring. When you were dealing with 3 minus x, and we factored, I told you if you ever needed to flip-flop those two things, you could actually factor out a negative, and it flip-flops and changes that to an x minus 3. And that's what we're going to do here, is all of our cofunction identities deals with 90 minus the angle, not the angle minus 90. So in order to find the cotangent of alpha minus pi over 2, which is what we're looking for, we're going to take and factor out a negative. And we're going to write this as the cotangent of, I'm going to put it in brackets, negative, in parentheses, pi over 2 minus alpha. So when I factor that negative out, it flip-flops the stuff inside parentheses. Now wait a minute, I've got the cotangent of a negative now. Let's go up and look at our even and odd identities. The cotangent of a negative, right here. Anytime you have the cotangent of a negative, that negative, because it is an odd identity, can be moved out front. So we can now write this as the cotangent of a negative can be written as the negative cotangent of pi over 2 minus alpha. So that's what we're looking for, is the negative cotangent of pi over 2 minus alpha. And if you'll scroll back up, this now fits an identity. The cotangent of pi over 2 minus alpha, the cotangent of pi over 2 minus alpha, or minus an angle, is equal to a tangent. Okay, so we can now replace that with the negative tangent of alpha. So now let's go back over here and work with this sum. I know the tangent of negative alpha is this. So let's go back up with the tangent of a negative angle. The tangent of a negative angle, here it is. The tangent of a negative angle, that negative can be brought out front. So I could write that as the negative tangent of alpha equals negative 2.36. And if you look, the negative tangent of alpha is actually what I'm looking for here. We know it's equal to negative 2.36. So all this working down, the cotangent of alpha minus pi over 2 was equal to this, was equal to this, was equal to this, was equal to this. So therefore, what we're looking for is equal to negative 2.36. Okay, the last one, number 8. We're asked to find the cosecant of negative b, or negative beta. So let's scroll up and let's look. What is the cosecant of a negative angle equal to? Well, we can bring that negative out front by this odd even identity. So it's equal to the negative cosecant of beta. Now we're given the secant of beta minus pi over 2, which again is backwards. So we're going to have to, in order to get that to fit our identity, we're going to have to do the secant of, and we're going to factor out a negative. And it's going to flip-flop this, and it turns it into pi over 2 minus beta. The secant of a negative. Now let's see what we do with the secant of a negative. It says right here, the secant of a negative, hey, you can just drop that negative sign. So the secant of a negative angle is the same thing as the secant of the positive version. So pi over 2 minus beta. And we were told right here that that's equal to negative 3.62. So the secant of negative, or pi over 2 minus beta, let's see what we can do with that now. The secant of pi over 2 minus beta is right here. The secant, oh no it ain't. The secant of pi over 2 minus beta is here, pi over 2 minus angle. We can replace this with the cosecant of that angle. So therefore, we are now told that the cosecant of that angle beta is also equal to negative 3.62. And we're asked to find the negative cosecant. Well, the negative cosecant of that angle, well, all we have to do is multiply both sides by negative 1. And you have the negative cosecant of beta, which is what you're looking for, would equal positive 3.62. So therefore, that would be your final answer.